Hello, this is Susan Poss. I'm an instructor in mathematics at Spartanburg Community College, and I wanted to talk with you today about multiplying with rational expressions. And again, the root word ratio means that we're talking about fraction form. So on this one, we're trying to multiply, and the way you can see that is you see this raised dot in here between the two fractions on line with the fraction bars. So we're going to multiply, and then we're going to see if we need to reduce. And we're going to state any restrictions on the variables. So the way I like to handle this one, and you'll get comfortable so you can do most of this in your head without having to write it out like I'm going to do. But I like to get everything down to prime factors, that is, factors that are only divisible by 1 and itself. There's the times. Let me come over here and break down the 6 into 2 times 3. Whoops. 2 times 3. And the x, I've got 3 factors of x, and I've got 2 factors of y. Again, you won't, as you get comfortable with this, you will no longer need to write all of this down. I'm just doing this for illustration purposes as we start with our multiplying process. All right, let me double check that and see if I got everything right. So here's the 5, 2 factors of x, 1 factor of y. 9 breaks down into 3 times 3, 1x and 3 factors of y. 2 times 3, 3 factors of x, 2 factors of y. 3 times 5, 1 factor of x and 4 factors of y. So this is where, after you've done the factoring, so we factored everything, you start to come in and look for things that are common factors that can be canceled out. So the first thing I note is that 3 over 3. Here's a 5 in this denominator and a 5 in that denominator that I can cancel out. Let's take out this common x here with the common x down there. I can take a couple of factors of y up here with a couple of factors of y down there. Here's an x and an x in common, and here's a y and a y in common. All right, let me look around. I have an x, I have 3 x's up here. Do I have any more x's on the bottom to cancel with? Doesn't look like it. And I have a 2 up there, but no 2's down here. I think we're ready to put it all back together again. So I'm searching through the numerator. I see 1 times x times 1 times 2 times 1 times 1 times x. Out of all of that, I hope you see a 2x to the 3rd power. So now let's go across the bottom and multiply back together across the bottom. So I see a 3 times 1 times a couple of factors of y here, times 1 times 1 times 1 times a couple of factors of y there. So it looks like we have a 3, and I think I see 4 factors of y. Let me double check. 1, 2, 3, 4. Yes, so I'm seeing a 3y to the 4th. That's the multiplication of these two fractions. You end up with 2x cubed over y to the 4th. And the restriction on here, you've got to look all the way back at the original, is that x cannot be equal to 0 and y cannot be equal to 0. If they were, we would have a 0 in that denominator. All right, so let's try one more. That first one was using monomials or single-termed expressions. This one has some binomials. These 2 in the first fraction are prime and cannot be factored. But in this second one, I see a difference of 2 squares. On this x squared minus 4, I'm factoring. And I really can't do anything with this x squared. If you wanted to, you could write it x times x. All right, so now I'm searching around here, looking for things that are shared in common. So I see a full denominator x minus 2 there that I can cancel out with the x minus 2 factor. Again, that's multiplication in there. I can take one of these factors of x out in this denominator. And it looks like I'm finished now. Let me put it all back together. So 1 times x plus 2 times 1. and 1 times 1 times x. And again, we talked, don't be tempted to cancel these x's out. You can only cancel when these things are connected by times. You cannot cancel when these things are connected by addition. So again, if you go back and look for your restrictions, you would take the first denominator, set it equal to 0, and see that one of the restrictions on x is it cannot be 2. And if you take the second denominator and set it equal to 0 and solve, the other restriction is that x cannot be equal to 0. And again, because I had a second degree down here in this denominator, I was expecting a couple of restrictions there. All right, so I've got one more example I wanted to work for you on multiplication. This one's pretty challenging, so I'll try to take it slowly here. I'm going to take this first numerator, 3x minus 3, and remember our first step is to factor. So I'm pulling out the common 3. In this first denominator, I see a common x, so I'm going to pull out the common x. Put down the times operation. Factor this trinomial, x squared plus 2x plus 1. And in the denominator, I see a common 3, so let me pull out that common 3. So I'm going to have to go one more time. This would factor again. You can take shortcuts in how you write this. But for clarity, I'm just going to copy everything down again and factor a little bit further in that second denominator. So don't lose the common 3, and then let's go in here and factor this x minus 1 and x minus 1. So now I have everything fully factored, and remember, factoring is required because we can only cancel out common factors. So there's all that multiplication we talked about before. All right, so I see an x plus 1 in common here. And I see an x minus 1 common factor there. Oh, and I also see a common factor of 3. And I think I'm finished. This x minus 1 does not match that x plus 1. And I don't see a single x that I can cancel. So let me put it all back together again. Sort of multiplying things back together on the end. So 1 times 1 times 1 times x plus 1. And then x times 1 times 1 times 1 times x minus 1. Okay, so when you're writing these answers, do you want to multiply this back together, or do you want to leave it in factored form? It's kind of a general rule. That you want to leave the denominator factored. It's kind of up to you. I like to leave it factored in case I want to do something else with it later on. It's already in factored form. So that's the general rule I would suggest that you follow.